Hi everyone. In this lesson, we will discuss the abstract view of the linked list data structure and how to perform insertions in a linked list. So let's get started. Before we dive into linked list, let's first discuss the problem with arrays. To insert a new element in the middle of an array, all the elements after that position must be moved to the right. For example, to insert this element 35, all these elements must be moved to the right. Similarly, when you delete an element, all the remaining elements after it need to be shifted to the left. For example, if you delete this element 35, all these elements need to be moved to the left. Because of this constant shifting, insertion and deletion in arrays are slow and inefficient. But in linked list, we excel in inserting and deleting elements. A linked list is made up of a chain of nodes, where each node contains two paths. One part contains the data, and the next part contains the pointer to the next node. For example, in this linked list, the first node contains data 10 and the pointer to the next node, which contains the value 20, and so on. In a linked list, each element is called a node. Every node is made up of two parts: a data part which stores the actual value, a next part which stores the pointer to the next node in the list. For example, in this linked list, the first node's address is 100, the next node's address is 101, and the third node's address is 102. The next part of the first node stores the address 101, which is the address of the second node. And the second node stores the address 102, which is the address of the third node. These addresses need not be in a sequential order like this. Each node can be stored anywhere in memory, and the pointer simply links them together. This is how we define a node class in C++. We define a node class with two members: a data member to store the data, and a next pointer, which is of type node. The constructor initializes the node's data and sets the next pointer to be null, meaning it does not point to any node yet. Now let's talk about insertion in linked list. Insertion in linked list can be performed at the start of the linked list, that is, before the head pointer, and a specific position of a linked list, and at the end of a linked list. To insert an element in front of the head node, we create a new node with a given value, and then we assign the next part of the new node to the head pointer, and then we update the head pointer. For example, to insert this node 5 before the head pointer, we create a node with the value 5, and then we assign the next part of the node to the head pointer, and then we update the head pointer to the newly created node. To insert an element at a specific position of a linked list, we create a pointer called temp and assign it to the head, and then we use this temp pointer to traverse to the node before the node at the specific position. Let's call this node the n-1th node. Unlike arrays, linked list use an 1 based index. The first element of the linked list is stored at index 1. The second element is stored at index 2 and so on. And then after traversing to the n-1th node, we assign the next part of the new node to the n-1th node's new node. For example, to insert element 25 at index 3, we traverse to the index before index 3, that is index 2. And then we assign the new node's next pointer to the next pointer of the n-1th node, which is index 3. And then we take the next pointer of the n-1th node and assign it to the new node. At last, to insert an element at the end of a linked list, we simply traverse to the last node and assign the next part of the last node to the new node. Here, let's create two overloaded functions called insert. One to insert data at the end of the linked list and another to insert data at the specific position of the list. Let's first create the one to insert at the end of the linked list. It takes a single argument of integer. Let's create a new node with the given data. Then let's create a temp pointer and assign it to the head. If the temp pointer is null, then we assign head to the new node and enter the function. If the head pointer is not null, we use a while loop to traverse to the last element. After reaching the last node, we take the next part of the temp pointer and assign it to the new node. The next insert function takes two arguments. The data to be inserted and the position where the data should be inserted. Let's create a new node with the given data If the position is 1, then we assign the new node's next path to the head. Then let's assign the head to the new node. If the position is not 1, then we create a temp pointer and assign it to the head. Now we traverse to the node before the position given by the user. Then we assign the new node's next path to the temp pointer's next path. And then let's assign the temp paths and then let's assign the next part of the temp pointer to the new node. Now let's create a function to print the data in the linked list. Let's create a temp pointer. And then let's use a while loop to reach the end of the node. And then let's print each data. Now let's use this linked list class to create a linked list. Let's create a list with 3 values, 10, 20, and 30. Then let's insert a value 25 at the third position. And then let's print the list. Now let's run this program. we can see that the linked list is created. I will be posting all this code in the GitHub repository. You can check it out. And stay tuned for future videos.